Math 1030, section 10.6, radical equations. So in the previous sections, we've been working with properties of radicals. Now we're going to use that to solve some equations. So if we look at something like square root of 2x plus 3 equals 5, seems simple enough. What we need to do is get rid of the radical. Now remember, it's an equation. You can do whatever you want so long as you do it to both sides. So what I'm going to do in this case is square both sides to get rid of the radical. 2x plus 3 equals 25 because square and square root cancel each other out. Now we get a very simple equation to solve. Minus 3 minus 3, 2x equals 22 divided by 2. X equals 11. Now I know what you're going to say, Professor, that looks a little too easy. What you have to be careful of with radical equations, if you have to make sure your solutions are valid. Does 11 work? Well, the short answer is maybe. We got to figure that out. If we plug 11 back into the original equation, it doesn't make sense. 2 times 11 plus 3 is 5. That's 22 plus 3 equals 5. Square root of 25 is 5, which means 5 equals 5. Which means, yes, 11 is a solution. Now, if we got something weird over here, like 6 equals 3 or something that doesn't make sense, then it would be no solution. Let's try another example. What if we have square root of x minus 3 plus 6 equals 5? Now, you're allowed to square both sides, but what we want to do is isolate the radical term first. We want to get this thing by itself. So what I'm going to do is subtract 6 from both sides. Square root of x minus 3 equals -1. And then we'll do what we did on the previous problem, which is square both sides. Plus 3, x equals 4. Is 4 the answer? Well, maybe. If I do square root of 4 minus 3 plus 6 equals 5, square root of 1 plus 6 equals 5, that's 1 plus 6 makes 5, 7 equals 5. Last I checked, 7 is not equal to 5, so this does not work. Which is okay. It doesn't mean you've done anything wrong. It simply means the equation is no solution. Which can happen like we've seen in the past. Okay. Let's try something slightly different. X plus square root of 26 minus 11x equals 4. Now, same as the previous problem, we need to isolate the radical, meaning we got to get rid of the x, subtract x from both sides. Square root of 26 minus 11x equals 4 minus x. Now again, our plan of attack is going to be to square both sides. This makes 26 minus 11x. Now on the right side, don't be lazy. We can't say 16 minus x squared. We have to say the quantity of 4 minus x times itself. So what I would do is just go off to the side and write it twice. Just say 4 minus x times 4 minus x. 16 minus 4x minus 4x plus x squared. 16 minus 8x plus x squared. Now, what we get is not as easy as the previous problem, but we'll use the same process. Let's get everything on one side. Minus 26 plus 11x plus 11x. What do we get? X squared plus 3x minus 10. Now, it's a quadratic, and that should look familiar. We've done a lot of work with this. So how do we solve this? Well, can we factor it? What multiplies to make -10 adds to make 3? x minus 5x plus 2. This times this makes this. No, that's wrong. This needs to be plus 5 and minus 2. This times this makes this and this make this. There we go. So we can then say x plus 5 equals 0, x minus 2 equals 0, x equals negative 5, x equals 2. Now these are two maybe answers. I don't know if these are actually valid. It's possible they both are, it's possible neither of them are. So let's check. Go back to the original equation. X plus square root of 26 minus 11x equals 4. What about x equals negative 5? Negative 5 plus square root of 26 minus 11 times negative 5. Negative 5 plus square root of 26 plus 55. Negative 5 plus square root, let's see, it's 81. That worked out kind of nice. Square root of 81 is 9. Negative 5 plus 9, 4 equals 4. Which means negative 5 does check out as a solution. What about 2? Let's find out. X equals negative 2. Negative 2 plus square root 26 minus 11 times negative 2 equals 4. Negative 2 plus 26 plus 22 equals 4. That's 48. Something's not right. That's positive 2, not negative 2. Positive 2. That's more like it. The square root of 48 didn't look right to me. 26 minus 22. There we go. Square root of 4. Square root of 4 is 2. And last I checked, 2 plus 2 is equal to 4, which means both of these are valid solutions, which means the equation has two solutions. Now, if you look at this problem, yeah, there's a lot of writing here. Isolate the radical, square both sides. I had to use some FOIL method over here. We got a quadratic, factor and get two solutions, but then we had to check both of those solutions. So try out the practice problems. They're going to work much the same way. Try those on your own. If you look at the first one, square root of 3x plus 4 equals 8. Well, you'll do the same thing here, square both sides. 3x plus 4 equals 64, and you get a nice easy equation to solve. Does that work? Well, maybe. 3 times 20 plus 4 equals 8. 60 plus 4 equals 8. Square root of 64 equals 8. 8 equals 8. Checks out. 20 is a valid solution. Now on this one, just like we saw before, we have to isolate the radical. Subtract 7. Square root of x minus 1 equals negative 5. Square both sides. Does it work? Maybe. Square root of 26 minus 1 plus 7 equals 2. Square root of 25 is 5 plus 7 equals 2, which means 12 equals 2. Well, 12 is not equal to 2, so that does not work. Therefore, this is no solution. Okay. Now on this last practice question, square root of 6x plus 7 minus x equals 2. Move the x over. Square both sides. Now again, just go off in the margin here and say 2 plus x, 2 plus x. 4 plus 2x plus 2x plus x squared is 4 plus 4x plus x squared. Combine like terms. X squared minus 2x minus 3 equals 0. And then again, we're going to factor. That'll be x minus 3, x plus 1. This times this makes this and this make this. X minus 3 equals 0. X plus 1 equals 0. X equals 3. X equals negative 1. Maybe. Let's see if these actually work. Square root of 6x plus 7 minus x equals 2. What about x equals 3? That's 18 plus 7 minus 3 equals 2. Square root of 25 minus 3 equals 2. 5 minus 3 equals 2. 2 equals 2. We're good. 3 works. What about negative 1? Negative 6 plus 7 plus 1 equals 2. Square root of 1 plus 1 equals 2. 1 plus 1 equals 2. 2 equals 2. Checks out. These are both valid solutions. Okay, now everything we've done so far has been square root. Let's look at what we do if it's cube root. All right. What if we have 3x plus 1 raised to the 1/3 plus 4 equals 0? Now here we're using a rational exponent. This problem could very well have been written as cube root of 3x plus 1 plus 4 equals 0. It means the same thing. Similar to the previous questions, we're going to isolate the radical term. Instead of squaring both sides, I'm going to cube both sides. 3x plus 1 equals 4 times 4 times 4 is negative 64. And then we get a fairly easy equation to solve. But by 3, x equals, what is that? 20. Doesn't go evenly. Negative 65 over 3. Now you might be asking if we need to plug that in and check for anything that doesn't work. Well, the thing here is that if we plug this in, well, we're going to get something that does work. Because you can take the cube root of a negative. Cube root of 3x plus 1 plus 4 equals 0. Negative 65 thirds. If I plug that in, Threes cancel out. Negative 65 plus 1. Negative 64 plus 4. Now again, you might look at this like, no, we can't do it, but you can take the cube root of negative 64. What times what times what makes negative 64 is negative 4. Negative 4 plus 4 equals 0. 0 equals 0. It is a valid solution. Okay, practice a similar problem. What if we had 2x minus 3 raised to the 1/3 plus 3? Do it the same way as the last one. 2x minus 3 to the 1/3 equals negative 3, and cube both sides. 2x minus 3 equals negative 27. 2x equals plus 3, negative 24. X equals negative 12. If you don't trust me, we can plug it in. 2 times negative 12 minus 3 to the 1/3 plus 3 equals 0. Negative 24 minus 3. Negative 27 to the 1/3 plus 3 equals 0. Cube root of negative 27 is negative 3 times negative 3 times negative 3, which is negative 3. And 0 equals 0, so it does work in this case.